This is Jane Low, and I'm at Black Hat Asia 2024 here in Singapore. And with me today, I'm very pleased and very privileged to have two cybersecurity experts, Adrian and Mary Walker from Dropbox, who has presented earlier in the session about LLM, which is large language models, vulnerabilities. So thank you so much for your time today.
Sure, thank you for having us.
Yeah, thank you.
Yes, when we talk about AI and in the minds of everyday people like myself, right, we have played with chatbots and we sort of understand some of the hallucination aspects, how the data could be poisoned and the outputs could be what we call garbage in, garbage out. But in fact, these are sort of vulnerabilities or weaknesses manifest a lot earlier before the model has been deployed. So it manifests during the model development stage. So for our audience who are not too familiar with machine learning and large language models, can you take us through a very brief overview of how that model development process is like?
Yeah, so first of all, a lot of people who use ML don't actually train their own models. They use other people's models. So that is one way that many people get involved with ML, is they go out to public repositories and find a model someone else made that fits their purposes, just like the rest of software development. But if you're making your own model, you need a lot of data, and that data needs to be well sorted and categorized and labeled more often than not.
Mm-hmm. Oh, I was just going to say, for folks that don't know much about the format of ML models, machine learning models are basically lots of layers of different things. So data points and weights and then configuration about the model are all kind of like nested dictionaries that make up these model formats.
So one example of a model is, of course, a language translation model, right? Yeah. Right. So you're talking about there's two possibilities. So either develop in-house with your own data, or you go to a third party and open source type of models. So there's two different, ways of developing a model.
Yeah, or of course you just consume a proprietary model as well.
So when it comes to some of these vulnerabilities, I think when it's the third party or open source model, I think it's quite similar to open source software sort of vulnerabilities and weaknesses, so there's no difference there?
Pretty much, yeah. So our research at Black Hat is basically spelling out that the supply chain attacks that you see on software dependencies, like in the Python software dependencies or NPM, those kinds of attacks are applicable in a machine learning context.
And then when it comes to using your own sort of data, which is the second method, what are the vulnerabilities there?
If you're using data, you have to be very careful about the bias that your data may introduce to the end result, either intentionally or unintentionally. And there is many, many case studies that have been done on, when you take a set of data and you try to make inferences from that data, you get a lot of unintended consequences because the model training process, it can fixate on things in a data set that maybe you didn't think about. So for instance, you might have a data set trained on, to detect, say, people's information about people's credit score, their credit reliability, and the system, unbeknownst to you, might fixate on things like zip codes and introduce bias. But the data sets themselves can also be poisoned because take a open source data set like Lion 5 billion, which is a huge image data set of 5 billion images. That data set is just basically a spreadsheet that has domains in it with the location of an image and the associated labels. But the domains expire, so people can buy the domains and replace the images that end up in the data set, right? There's so many different things that can go wrong with that too.
So the data, you're saying, because it's could be outsourced, or it could be third-party data, like referencing a domain. And if the domain is a malicious domain or contain corrupted data, then you end up training your model on corrupted data. Yeah. What about data that you internally sort of store in-house? Is there any vulnerabilities there?
You might not have enough data internally to train a model appropriately. You need a huge amount of data to do certain things. So that's one risk, that maybe you have less risk of data poisoning, but your model is less robust because you don't have the amount that you need, for example.
and which will often lead to unintended consequences when it comes to like bias and things like that.
So when it comes to, if I could just go back to the point about third party and open source, reliance on open source models, is there any extra sort of precautions machine learning scientists or engineers have to take care of compared to like a typical software developer?
So the first thing is they need to be aware that the models can contain malware, for instance, right? That when you source a model from the internet, you're effectively downloading and running an unknown program. And that's something that we need to spread the good word on, so to speak.
Yes.
We've been
So
trying to do that.
at the moment, what you're saying is that a lot of people take for granted that it's safe and...
Yes.
Yes.
Right, okay.
They assume that the model is basically like a bunch of numbers, arithmetic.
Like a lot of if then else kind of statements and
Yeah.
just numbers and weights, and that's not always true.
So how would a threat actor, for example, corrupt some of these models compared to, say, a typical software program or algorithm? Is that a different?
Yeah, they've kind of got two options, and it would depend on your industry, for instance, or the function of the model, which or both you care about. So if someone was to backdoor a model, they may change its ability to classify certain images. So like, let's say you work in a defense company, you'll be very worried about someone backdooring an image classification model because maybe you're using image classification to detect certain shapes, like the shape of a tank or the shape of a missile. And if someone can backdoor the model, they could make it miss like certain kinds of missiles or certain kinds of tanks. And that would be very, very bad. The other way is that they literally insert malware into the model, which was what we were mostly talking about at Black Hat. And that effectively, depending on the model format, the basic process is that in the model's architecture, you just add code that executes during the model's inference or training phase. Like basically when the model starts up as a program, it has an initialization phase of like any program. And during that point is a nice place to insert.
Is a threat actor's expertise when it comes to corrupting a ML or AI model different from a typical threat actor that we know of?
I think it's kind of all over the place. I think we have some evidence that there are some APT groups doing, very sophisticated things, but you don't have to. The vector that Adrian's discussed and documented is quite simple to use. Anybody that can operate a C2 could use that in a model. So it's all levels, I would say.
And what would their motivations be? You mentioned, I think, three possible motivations at your talk. One is to extract data, obviously, gain access to, I guess, the corporate network. And then the other one...
like poisoning a model.
Yes, that's right, poisoning a model.
Yeah.
So those are the three motivations.
Yeah, those were my motivations.
Those are what you think they are after. Okay.
But other motivations that we see from threat actors is if you're targeting a machine learning pipeline, what does a machine pipeline have a lot of? It has a lot of GPUs.
Yeah.
What can you do with GPUs?
Mine coins.
You can mine coins. You can mine a lot of coins really, really fast. And if an attacker gets into your machine learning pipeline and they decide to mine coins, you just got off very easy.
Yes, it's the best case scenario.
Yeah. You basically just paid a bug bounty, right? Because the worst thing they could have done is probably steal all of your business's data or ransom you or extort you. Or they could do something sneaky like poison a model. And depending on your industry, an attacker poisoning one of your models, like in defense or social media or something like that, it could be very, very bad.
I think in many people's minds, AI sort of like burst into the scene only like in the last 1 year or so, right? But I am presuming that the threat actors have been exploiting these vulnerabilities for much longer than this recent 1 year.
Yes and no. So if we think about like malicious models, with certain model formats, it's been known that you can do malicious things with them for quite some time.
Yeah.
Because of pickles, like Python pickles, and the history of malicious Python pickles goes back a long, long time. But I think people's understanding of the space and the complexity of attacking these systems, or lack thereof, has meant that we're starting to see a lot more attention in the space.
Yeah, I mean, the pickle stuff is more documented and more well known, and that just tracks back to all of the problems with serialization that we've been dealing with for a long time in the industry. But the attention on like the ML environment as a great place to operate and using these other attacks is certainly new, and I think threat actors are starting to pay attention because of the rise of AI, and not just because maybe it's more on their mind, but also because companies are investing more heavily into it. So it becomes a more juicy environment to target when companies are doing things with these machine learning things.
Yeah. Basically, if you're trying to do a supply chain attack on a business, like a software supply chain attack, there needs to be change, because if there's no change, your code won't go from outside the business to inside the business. And because of AI and everyone rushing to use it, it means there's a lot of change.
Yes.
And to use AI effectively, you need to use a lot of ML, which means there's a lot of things going from outside to inside. Right. So it's a really good time to do the attack, because there's a lot of movement and change.
Okay. You were talking earlier about, well, would you want to use an open source model or a private model? And really, I think you need to think about like these machine learning models like Python, like PyPy packages, kind of like NPM packages. A machine learning engineer could maybe write a model to do entity extraction, but why would they, when there's a perfectly suitable one on Hugging Face that they can just pull into the environment and use and not have to train it or worry about it? So, but with that, of course, comes risk and all of these problems that we've been dealing about with in other supply chain things.
So when it comes to security mitigations, then in terms of the defense tactics and attention that needs to be paid, we're talking about traditional security practices still matter. So for example, when you bring information or source code from the outside environment into the inside environment, there's, I guess, a traditional sort of best practices that has been around for a long time, that those still have to be sort of followed. But it's getting challenging because of this rush to deploy as much as possible, that the attention paid to those is becoming secondary.
Yeah, I'd say that's pretty accurate. Yeah, there's a lot of lessons I think we learned from NPM and all of those kind of things that need to be applied to the ML space, and we need to, give folks that are working in ML good tools to assess things coming in, and information on how to make the environment as secure as it can be. All those kind of things. There's a lot of work to be done.
Yeah, the model formats themselves do complicate the process of assessing them. Just their size alone can complicate the process of studying what a thing is. Right, okay. And you see this as a long-standing issue with antivirus scanning, and EDRs is a very popular evasion technique for a long time, was simply just to pad out a file till it was too big to stick in a sandbox. Yep. And machine learning models are coming out the box at 200 gigabytes, 300 gigabytes, and it presents a challenge. Just even that, let alone all the other complexity.
So what is the one immediate thing that cyber defenders should do?
I think the most important thing in that space is to understand what your company is doing in the machine learning space, what the machine learning environment looks like, and if you're prepared for an incident in the space. Are you logging how you should be? Do you have visibility? Can you take containment actions there? So that if a model is malicious and it executes in your environment, you can respond to an incident in that space. And then there's, securing the supply chain and all of that. That's important, and that's work that needs to be done, but it's potentially quite a bit harder than simply learning the environment and preparing while you're simultaneously trying to make sure that you're not bringing in bad things.
Yeah, don't let the first time your incident responders have seen or learned about the ML pipeline be during a real incident, because it's pretty complicated. And you don't want to be learning that under stressful conditions. You want to tabletop that at least, or you at least want to know, as Mary said, like if we have a model coming from a public repository, what does the flow of that look like to getting to the point where people are doing inference on it? Mm-hmm. What does that deployment pipeline look like? you should know about that in advance.
Yeah, is this an environment that's highly containerized? And do you have appropriate tooling to look at, do container introspection? Is that something you need in your environment? I think sometimes defenders, we get, overwhelmed by how disparate the prod landscape can be for companies, but just kind of to look at, understand what technologies are in place from the host all the way up to the inference and all of that. So just every kind of stack to understand what you can see and what you can do from a IR perspective.
Yeah, I think in the traditional cybersecurity space, there have been a lot of talk that, there's always a lot of playbooks in the case of a crisis communication or in an incident, in a cybersecurity incident. But there's maybe not so much attention paid to actually rehearsing that lesson kind of apply here as well.
Yeah, so a cool tabletop or exercise your red team might be able to do for you might be a malicious model, a supply chain attack. But it could also be an assumed breach scenario where you say something like the same, or maybe a model has been poisoned. What now? Because take, for instance, a business has fine-tuned a model for their own purposes. The process of taking an open source model and then adding in your smaller data sets of your own business's own data, or maybe you've trained one from scratch. If an attacker poisons that, what are you going to do?
That's a good point. That's something that's very different, isn't it? And unique to a machine learning
it
AI
could,
environment.
Depending on the state of, say, backups, that could knock that service offline for weeks.
Yeah, and do you know what changes were made, what changes were valid, where are attacker changes coming in, all of those kind of things. So it's definitely, you need to partner with the people that are using these things to make sure that they're prepared as well. Yeah.
And there's an easily calculable cost with this too, because GPUs right now are very expensive. And if you're training models and then having to retrain them because an attacker touched them,
that's a good point.
Like that's an easy thing, an easy narrative to sell, because the cost of GPU training time is like a big number and easy to calculate.
Yeah, that's a very good point, actually. So just as a final question to wrap up the podcast, do we know of any sort of high-profile, breaches when it comes to AI models?
Yes. There are some, that's public. Okay, that's an easier one to answer. The biggest thing we're seeing at the moment, I think, is cryptocurrency miners targeting pipelines.
Oh, wow.
And as I mentioned earlier, and Mary as well, that's you getting off easy. But it's a signal or a type of bellwether of where the offensive market is going, that all across the industry of different conferences I go to, I see more supply chain attacks. Yes. Right? The state of defenses is pushing people towards performing these kinds of attacks. So I would say that there's a report by Oglio on threat actors using these kinds of vectors. And JFrog also has a report on pickle-based models, PyTorch-based models. And there are some flat-out aggressive payloads in that mixture of infected models, amongst ones that are obviously bug bounty hunters or people just doing POCs, opening the calculator. There are people doing properly malicious things.
Right, so it seems like it's becoming a attack vector for attackers now.
Yeah.
In addition to phishing and all sorts of other social engineering.
Yeah,
vectors.
And a little bit of color I can add of some somewhat public information is some APT groups are starting to build out machine learning attack toolkits that are designed to target ML pipelines and so on.
It's only going to get worse. We're at the kind of cusp of adversaries learning that these are great things to target. So it's just going to get worse.
So they're building AI tools to target these AI models. Wow.
That was the thing. But I think these toolkits I'm referring to, they have limited AI capabilities themselves. They just target AI systems.
Right. Okay. So it's definitely emerging. and very important
Yeah.
area to pay attention to. Okay, so it's not just, when we talk about AI for consumers like myself, we think about, some of the data, like as I was saying earlier, garbage in, garbage out. So we kind of know, okay, this answer from ChatGPT is just doesn't make sense. But for the more subtle sort of manipulations, that's probably not so obvious for everybody to catch, and especially when it comes to company data and where it's just numbers. So so thank you very much, Adrian and Mary, for your time today to take us through, very briefly, some of the machine learning and AI vulnerabilities. And it's a big space to watch, and I think we're just really just scratching the surface today, even though we have been talking for 30 minutes, and you have been presenting earlier for close to an hour.
Yeah. And we can put some information in the show notes, I guess?
Yeah,
Cool.
please do.
Yeah.
Yeah.
Cool.
Yeah, thank you so much for your time today.
Of course.
Thank you.
you.